So let's have a look at the steps for planning a project without resources. So first of all, you need to create a project in Oracle Primavera P6. You need to have a name and an ID. You then go and define the calendars. You then define the project breakdown structures in other codes. So typically you would use the P6 WBS function to create the work breakdown structure, and then there are several other methods of coding up your activities. You then add the activities, and then you add the logic links. And the PMI talk about mandatory dependencies, discretionary and external, and I'll go through and explain what those are later on. You then schedule the project, which will calculate the start and finish dates, and then you need to consider contingent time, and there are various methods of assigning contingent time, and again we'll discuss them later on. So when you create a project in Oracle Primavera P6, you need the following information. First of all, you need an EPS node, which you create as part of maintaining a database, an OBS node that assigns security. Then you need a project ID, which is a code assigned to the project, and it is a unique ID within the database, and you need to have a project name. You always need a project start date, and also if you want to, you can put a project finish date. I generally recommend you don't use a project finish date, and I'll explain why down the track. You need a rate type, and Primavera P6 has 5 resource rate types, and you have to select a default one, and normally most people just accept the default that's given. And any other relevant information such as location, customer, client, and that sort of thing. Next thing we do is define the calendars after we create the project, and these define the work periods, holidays, and shifts for any activities or resource calendars. There are 3 types of calendars in Oracle Primavera P6. First of all, they're global calendars, and these calendars may be assigned to any activities or any resources in any project, and these are usually maintained by the administrator. Then there are project calendars, and these are project-specific calendars that may only be assigned to activities within a project. They may not be assigned to resources. And then finally, there are resource calendars that may be assigned to resources for resources that have specific working requirements. For example, individual people might have holidays and that sort of thing. My recommendation as a default is only to use project calendars. There is an issue with using global calendars because if somebody changes a global calendar, then your project will be affected and you don't know that that's been changed. So normally in construction, most people just use project calendars, but obviously there are times when you want to use global or resource calendars. Next thing we do is define the project breakdown structures. The primary project breakdown structure in P6 is the WBS, or it's also called work breakdown structure, and this is a hierarchical structure, and generally the first thing I'll do is create the WBS. It's used to categorize activities into deliverables, and you can have a code structure if you want to, or just accept the defaults. And if you put in your own code structure, this may be used to assist in management reporting of the project. After the activities being created under the WBS, they may also be assigned activity codes and user-definable fields, which further assist in grouping, sorting and filtering of the project schedule. These may be created and added later, but you really do need to create WBS before you start adding the activities. Now we've created the project and we've got the calendars and the WBS created, then you're in a position to add the activities. And you need to consider the following things when you add activities. You need to decide what the scope of the activity is, what's included and what's excluded. You need to know the activity duration. You need to know who's going to complete it, who's responsible for it, the deliverables or outputs of the activity, and you need to ensure that the activities are measurable and specific. So you need to ensure that you know how you can record progress of that activity. Next thing we need to do is add the logic. And the PMI defines 3 types of logic. They talk about mandatory dependencies, discretionary dependencies, and external dependencies. So let's discuss mandatory dependencies. First of all, mandatory dependencies are relationships between activities that can't be broken and possibly don't need to be defined in the methodology statement. So for example, you have to put in the Rio before you can pour the concrete, or you have to dig a hole before you pour the concrete into a hole, and that's a mandatory dependency. Whereas a discretionary dependency determines the order of work. So if you've got 4 holes to dig in a field, are you going to dig one at a time with 1 excavator, or 2 at a time with 2 excavators? And are you going to start with the one nearest the fence or the one nearest the gate? So the discretionary dependencies determine the order of works and are often directed by the methodology statement. The last one is external dependencies, and these are the dependencies that are out of the control of the project manager. You would often find them in the contract documentation or scope documentation, might represent when the land's available to start work or when you have to hand over the works to the customer. And so external dependencies are normally identified by milestones and usually put at the top of the project. Developing a closed network. A project schedule is not considered a critical path program unless it has a closed network. So a closed network is when every activity except the start milestone and the finish milestone, these can be start activities and finish activities, but I normally like to have a milestone at the start and finish. Every activity except the start and finish milestone has a start predecessor and a finish successor. So it has a predecessor coming into the start of the activity and a successor going out from the end. Therefore, in this situation, any activity, if it's delayed, will eventually delay the end date, and therefore a closed network must be generated if you're going to create a critical path program. Scheduling the project. So when a schedule has a closed network, then the scheduling of the project will identify the critical path, the total float, the free float, and other useful data such as driving relationships. So let's have a look at each one of these now. So critical path or critical paths. The critical path is often defined as the shortest duration a project may be completed in, and a delay to any activity will delay the end date of the project. So this is the critical path, which is shown in red. We're not working Saturday and Sunday, and that's why we have a gap here. And so this is the critical path and a delay to any activity. So these activities here, because it's a closed network, if these get delayed beyond the end milestone, they'll go onto the critical path and delay the end date of the project. So an activity may be delayed by delaying the start, increase the duration, or splitting the activity, but unfortunately P6 doesn't have the ability to split an activity, so if you wish to split an activity, you actually need to create 2 separate activities. So when you reschedule the project, it should calculate the critical path for you. Total float. So when you schedule a project, P6 will calculate the total float. And total float is the amount of time an activity may be delayed without delaying the end of a project. So this activity here has 8 days float. It may be delayed 3 days here and 5 days here. And after it's been delayed 8 days, it will go on the critical path. And if you delay it more than 8 days, then it will delay the end date. So an activity with float may delay another activity. So this activity has 11 days float, so it can get delayed 3 days, and then it will start delaying this one. And if it gets delayed 11 days, then this activity and this one will be on the critical path. And if you delay it more than 11 days, it will then delay the end date of the project. The total float may be displayed in a column or as a bar, and you can see it's a solid black bar, but these may be formatted to your requirements. And also total float may be negative, and I'll explain what it means by negative float and how you generate negative float in a slide in a few minutes. Next we want to talk about free float. Free float is the amount of time an activity may be delayed without delaying another activity. So you can see that this activity may be delayed 3 days before it delays that one, and therefore that is the free float. The free float may only be displayed in a column and not as a bar, and it is never negative. So free float is the amount of time an activity may be delayed without delaying another activity. We're not working Saturday and Sunday, and therefore if this gets delayed 4 days, then it will finish on Monday. Now I want to talk about relationship colours. You'll see in P6 that the colour of the relationships is different. It can be red or solid black or dotted black. And red are critical, and therefore the activities normally do not have total float. And then solid black, these ones here and this one here, are described as driving non-critical. So these activities are not critical, but this solid black one determines the start date of this activity and not this one. So solid black are defined as driving and non-critical, and the successors will therefore have float. And then you'll find there's dotted black. This one here is dotted black and that one's dotted black. These are non-driving, non-critical, and therefore their predecessors have free float. This activity has free float, and this activity has free float. Some people go and delete these because they're saying they're not doing anything. That's not a good thing to do, because then the free float won't calculate correctly. So you see that unlike Microsoft Project, where Microsoft Project adopts the color of the relationship from the predecessor activity, P6, the colors mean either they're critical or they're driving non-critical or non-driving non-critical. Also, when you select an activity, the relationship goes blue and you can edit it or delete it. Now I'd like to talk about constraints. To correctly model the impact of events outside the logical sequence, you may use constraints, and a constraint would generally be imposed to specific dates, such as the availability of a facility to allow work to commence, or the predetermined time a project must be completed by. Constraints would normally be cross-referenced to the supporting documentation, such as contract documentation, milestone dates, and I would use the notes function to take notes about a constraint. Constraint types. There are two types of constraints in P6. First of all, the project constraints, which includes the project start date and the project finish date. You must set a project start date, and no activity will be scheduled before the project start date, and therefore the project start date acts like a constraint on all the activities. And there's an optional project finish constraint or finish date that I recommend you don't use, and I'll explain why. It's a predominant feature in the software and therefore you need to understand it, and I'll talk about that in a minute. Then there are activity constraints. There are quite a number of constraints similar to Microsoft Project and other products, but the two most common are start on or after, or finish on or before. And the start on or after is also called an early start constraint, and the finish on or before is called a late finish constraint. First, I want to talk about project constraints. So when you set a project finish constraint and it is after the calculated end date, what happens here is that you have a project finish date 5 days after the calculated finish date, and therefore we get 5 days float on activities that were on the critical path. So what happens here is you've lost the critical path and you're telling your contractors that you've got 5 days spare. And that's why I don't like using project finish constraint. So when the finish constraint is after the calculated finish date, you lose the critical path and all activities have float. On the other hand, the picture below shows a project finish date of the 12th of September, whereas the calculated finish date is the 19th. And therefore we have generated what's called negative float. So the project starts here and is calculated finish date here, but we've imposed a constraint saying we want it to finish a week earlier. Therefore we have to start a week earlier if we're going to finish a week earlier. So what happens when you set a finish constraint, a project finish constraint that is earlier than the calculated finish constraint, you end up with negative float that identifies the amount of time you need to catch up. So this date here is 5 days earlier, it's 1 week, but we're working 5 days a week, and float is calculated on a calendar, and therefore we have 5 days negative float, which represents the amount of time we need to catch up. Now let's look at activity constraints. So an activity will no longer start on the data date, which is this blue line here, and when you create a new project, the data date and the project start date are the same date. So an activity will no longer start on the data date when a start on or after constraint is assigned. So you can see here that we have a start date of the 1st of September, but we have a primary constraint date of the 8th of September, so this activity is held out on the 8th of September and the critical path is calculated from that date. You'll also see I'm showing the time here. It's very important that you show the time when you are operating P6, because often when you set a constraint, this time will be irrelevant. So it's really important that you display the time whenever you are using P6. I normally show the time in hours without the minutes to get a narrower column. But this is showing how a start on or after constraint operates, and this is also known as an early start constraint, and I'll explain why it's called an early start constraint later on. Okay, activity constraints continued. Now I have a finish on or before constraint assigned to this activity on the 22nd of September. So in this situation, it's worked in a similar way to a project finish constraint that's earlier than the end date and has generated negative float. So we have calculated that the project needs to finish or will end on this date here, which is the 27th of September, but we have assigned a constraint of the 22nd, and therefore we generated 4 days negative float. So we need to start on this day here, the 2nd of September, if we're going to finish on the 22nd. So a activity constraint, a finish on or before activity constraint, works in a similar way as the project constraint, but this will just operate on the one activity and not all activities. And negative float is created, representing the amount of time that needs to be caught up, and this is also more commonly called a late finish constraint. On the other hand, if you set the finish on or before after the end date, and this is the 1st of October, which is this Wednesday here, then what will happen is the critical path will be calculated and you don't end up with float like you have with a project finish constraint. Therefore, I prefer to have a finish on or before rather than the project finish constraint, because it maintains the critical path when the project is running earlier than the project finish constraint. So total float is not calculated to the constraint date when the constraint date is later than the calculated early finish, and therefore positive float is not calculated and the critical path is maintained. So this is why I prefer a finish on or before constraint rather than the project finish constraint.